So now that we know what a function is, we're going to try to find the domain and range of a function. Now, sometimes you can find the domain and a range of something that's not a function. That is possible as well. Most times, though, for our purposes, we're going to be working just with functions, but might not always be the case. Domain, as we've heard it before, is the set of all x values, right? So those are all my first values in the ordered pair, right? That's my left and right, how I travel left and right in the coordinate plane. And then the range represents all of my y values. Remember, y is the second value in all of my ordered pairs, and y represents how far up and down I move in the coordinate plane. All right? So in this first example, we're asked to find the domain and range for this relation right here. Okay? Now this applies to if I have a table or a mapping diagram or a list of values. This is how we would do that for those specific types of problems, given in that format. So the domain, I'm just going to list all of my x values, and I want to make sure that I do not repeat. When I'm listing, we do not repeat. Do not repeat values when we're making a list. Okay, so I'm about to list all of my x values. We can see here that we've got 2, 6, 2 is repeated, so I'm not going to write 2 twice. I'm just going to write it once. We also have -6. So when I write the domain, I'm going to use the braces, and now I'm just going to list all values of x which belong in my domain, right? So we've got 2. We've also got a 6. I'm not going to rewrite the 2. We've already included the 2 here. Don't do it twice. And I've also got a -6. That is all the values in my domain. And then we can look at the range, and we know the range is the set of all y values. So I can look at -3, 1, 5, and 8. And so I'm going to, again, make a list. I'm going to use the braces. We've got -3, we've got 1, we've got 5, and we've got 8. All right. To me, it doesn't matter what order you put these in. Some people like to put it in numerical order from smallest to greatest. Some people have other ways they like to do this, but for me, it doesn't exactly matter. So here, it's nice and easy because you can just say, hey, the domain is exactly these 3 values, and the range is exactly those 4 values. All right. So those we can list, and those would be your answers for the domain and range. When we have a graph, it gets a little bit different, okay? We're still gonna list the domain, which is all my x values, and the range is all my y values, but I have to use either an inequality or interval notation to describe the domain and the range. So I'm actually gonna have to erase this real quick so I have enough space up here. All right, so for the first one, again, domain is the set of all x values. So x is when I travel left and right. So as I go from -infinity, I make my way over. The graph doesn't even exist yet until I get to right here at this point, right? This is at -1, -2, -3, -4, -5. And if I go up 1, 2, 3, 4, 5, 6, 7, 8, here we're located at -5, 8. So I know as I travel from left to right, I'm just starting to hit values when I get to -5, right? Now, I'm not including the -5. It is an open dot. But then as I continue, I have x values forever, right? This keeps going, and it never stops. So I know that my domain, again, my x values, this is going to be anything that is greater than -5. All right, so my domain is all values of x bigger than -5, right? X does not exist if I'm over here at -6 or -8 or -10, right? The graph does not exist over here. It only exists when I'm greater than -5. All right, if I want to use interval notation, all right, we could say x is greater than -5, or I could say that I'm going from -5 to +infinity. That would be another way to do it. And then for the range is the set of all y values. So the highest, right, as I go from -infinity upwards, I have the graph, because this extends down forever. So from -infinity up, keep going up, and then we stop right here once I get to +8. Remember, this was at -5, 8. And so the highest y value, right, the highest y value we'll ever get to is +8. The graph does not exist up here or up here or up here or up here, right? So the highest y value we'll ever have is 8. So we know that the y value has to be less than 8, right? It's not less than or equal to. That'd be if it was a closed dot. But because it's just the open dot, we use the less than symbol. All right, and then I can also write this in interval notation. So if y is less than 8, I'd be going from negative infinity up to 8, but not including that 8. All right, so that's two ways you could write that answer. All right, again, y values, you're thinking up and down. How far down does the graph go and how far up does the graph go? And then for your domain, you're thinking left and right. How far left does the graph go and how far right does the graph go? All right, so I'm gonna have to unfortunately erase these answers, so hopefully you wrote these down and you're keeping track. Second one, again, I'm thinking about my domain, right? My domain is all the x values. How far left do I go and how far right do I go? So as I think about this, well, we start at negative infinity, right? That's way off to the left. This graph keeps going to the left forever, right? So from negative infinity off to the left, it continues along until we get right here to this point. Now this point is located at 1, 2, 3, 4, 5, 6 to the right, and then it's located at 1, 2, 3, 4, 5, 6, 7 down. So that means I'm going from negative infinity all the way to positive 6, and we are including the positive 6 because it's a closed dot. All right. The other way I could say this is simply that x is greater than or equal, x is less than or equal to 6, right? We start at 6 here. Anything less than or equal to that 6 would be a possible solution. All right, so two ways to write that, either interval notation or is an inequality. And then the range is how far up and how far down do we go? Well, I know the lowest it will ever be is here at negative 7, right? So the lowest we can be is at negative 7 inclusive, and it goes all the way up. It keeps going up, keeps going up, keeps going up forever. So the highest we can ever get to is infinity. So this would be interval notation, or I could just say that my y values are greater than or equal to negative 7. All right, for the next graph, hopefully you're kind of getting the hang of it now. As we look here, again, we're looking at the x values. So it looks like from this point all the way over to this point, right? This is going to be my domain, right? And that's my set of x values. So over here at this point, we're located at negative 1, 2, 3, 4, 5, 6, so negative 6. And then down 1, 2, 3, 4, 5, so negative 6, negative 5. At this point over here, we're located at 1, 2, 3, 4, 5, 6, up 1, 2, 3, 4, so 6, 4. So I can see that my domain goes from negative 6 to positive 6. And if I think about my range, whoops, too far. My range, the lowest it is at is negative 5, and the highest is at 4, and that's my range. So if I can think about how to write this using an inequality or interval notation, for the domain, we know that negative 6 is the lowest. It does not include the negative 6, so x has to be between negative 6 and positive 6 there. Or I could use interval notation, right? Going from negative 6 to positive 6. Again, this is not an ordered pair. That's not a point on the graph. This is interval notation. For the range, the lowest we can go is negative 5, and the highest we can go is 4. So y has to be in between negative 5 and positive 4. Or if we want to use interval notation, that's just from negative 5 to 4. Again, this is interval notation. That is not an ordered pair. All right. Over here, again, I want to think of x as my domain from left to right. And my range is from up and down, right? So domain, the farthest left we go is 1, 2, 3, 4, 5, 6, 7 to the left, and then 1, 2, 3, 4, 5, 6, 7 to the right. And so this is at 7, negative 3, and this is at negative 7, negative 3. So I know that my domain is going to be from negative 7 to to positive 7. We know x is inclusive in those, right? We have these closed dots at the end, so x is between these values, including those values. Another way I could describe this is using interval notation from negative 7 to 7. Now the range, the range from low to high, the lowest we ever get is negative 3, right? And the highest is up here, which is at 0, 1, 2, 3, 4, 5, 6. 0, 6 is the highest we get, all right? So to describe the range, we can say we can go from negative 3 up to positive 6. I want to include this 6. I'm also including the negative 3, so I want to use the less than or equal to symbols. And then I still want to use the brackets from negative 3 to positive 6 in the y direction. All right. This one here, again, my domain is from left to right. So my domain is going to be from negative 1, 2, 3, 4, 5, 6. From negative 6 is just less than x, right? So open dot. And less than or equal to 1, 2, 3, 4, 5, 6, 7. All right. So using interval notation, we'd be going from negative 6 to positive 7. And we'd include the 7, but not the negative 6. The range, well, the range is just this sliver right here. That's the range, right? It doesn't go up or down. It's just at this level right here, which is at positive 2. So the range is just 2. And we don't even need to use interval notation because the only value that the range could be is 2. For this next one here, kind of the same situation, but for the domain this time, right? My domain is literally just at 1, 2, 3, negative 4, right? The x value is only ever going to be negative 4. So we're going to say that the domain is negative 4. Now my range can vary, right? Because my range, the highest it goes is 2. And the lowest it goes is, let's see, negative 1, 2, 3, 4, 5, 6, 7, 8, negative 8 for my range. So we're going to say that it goes from negative 8, but it doesn't include the negative 8. And it goes all the way up to positive 2. Using interval notation, this would be from negative 8 to positive 2. And there you'd have it. All right, some a little bit more challenging ones, or just a little bit different ones. For this first one here, if we notice, this graph goes up and left forever and down and right forever. So for our domain is going to be all real numbers because it never stops going left and right. And it's actually the same thing is true with the range because it never stops going up and down forever. So we get all real numbers for both. For this one, if I look at my domain, well, this is going to keep going left forever and it's going to keep going right forever. So my domain is going to be all real numbers. Now my range is a little different though because it does have a lower value. It goes up forever, true, but the lowest value we get is positive 1 for my range. So for my range, we're going to say, we're just going to do interval notation for these. The lowest we can go is 1, and it does include the 1 because it's a closed dot here. And we can go all the way up to positive infinity. So the range would be from 1 up to infinity because it keeps going up forever. All right, for something like this, well, for my domain goes from this point to this point here, right, from left to right. So here we have an x value of 3, right, x value of 3 right there. And over here, the x value is at negative 4. So my domain is going to be from negative 4. Now, this is a closed dot here, so we got a bracket. And it goes up to 3. This is an open dot here, so we do a parenthesis. The range is from how high and low do we go. Well, the lowest we ever get is down here at negative 5, right? Negative 5 is the y value. And then we go all the way up until we get here, which is at positive 5. That's my range. So the range, the lowest we get is negative 5. It's a closed dot down here. So I'm going to bracket off the negative 5. And the highest we get is up here. Now there is an open dot here, but because it's a closed dot here, we can still include the positive 5 up top. And then the last one, well, we got a few different pieces here, all right? For my domain, let's think about this. Domain is from left to right. So it keeps going left forever. So I'm definitely going from negative infinity up to something. And so as I continue, I get all the way up here. Now it's a closed dot here, so it does still include the 1. We jump up here, and we continue across, and we still have all these values included. It's a closed dot here, so we still include that, and as we continue, it keeps going. So notice, if you look at this graph, there's no value of x that's not included. Every value of x is included. It starts going left forever. It goes to the right forever. It's all real numbers. Okay. Range, let's see. So as I move up from the bottom, the lowest we can get is right here at 0, right? My y value here is 0. And then as we move up, we've got every single point included, right? Because as this blue line goes like this, it's going to include every single possible y value, all right? So the y value are going to start at 0, bracket at 0, and it's going to go up forever to positive infinity. These really do not have any effect on the range because this parabola looking thing here is going to cover every single y value that we have. All right, so these don't really affect the range very much. They're just maybe there to throw you off a little bit. All right, so that is domain and range with tables.